Another way of making your codes faster next to memory pre-allocation is vectorization. So vectorization basically means getting rid of loops for a while and replacing them with directly vectorized, or you could call it metricized operations, so that you do something on the entire vector all at once rather than use a loop to visit elements. Not always eliminating a loop is possible, especially in case of while loops, because quite often we don't know in advance how many elements will be going into some vector, so that also refers to memory pre-allocation. But whenever it is possible, whenever the operation allows to make something vectorized, this is the right way to go in most cases. So just to give you an example, in the case where we were trying to create a new vector by multiplying elements of another vector, we did it twice with a loop, once with and without memory pre-allocation. But then if instead of using a loop we actually use this vectorized form, then that code needs about 2 seconds to do the 10 power 8 case and 64 seconds to do 10 power 9. Of course, 64 is still quite a bit, but if you think we reduced by nearly a third, or by more than half, this is about a third of the other solution, so this is an improvement still. And as another example, let's assume now that we have a matrix case. So we have a vector x, which can be anything. Let's say 1, 2, 3. This is a small case. And we would like to create matrix D, where every respective element ij has the respective difference of these vectors elements. So for instance, element 1, 1 would have x1 minus x1. Then element 1, 2, which is here, would be x1 minus x2, and then x1 minus x3, and so on. So the resulting matrix actually would be 1 minus 1 is 0, 1 minus 2 minus 1 minus 2, then there would be 1, 0, minus 1, and then 2, 1, and 0. So how do we do something like that? Well, for some, especially based on how this formula here is written, the most convenient way would be to write nested loops. So one loop goes through rows, one through columns, and we just create always element ij. So this is what is done in this code. We define our vector x. Now we take again some big case, so 10 power 4. Remember that if this vector is 10 power 4, then the actual D matrix will be having now 10 power 4 times 10 power 4, so that's again 100 million elements. Then we pre-allocate memory. This already we learned from previous part. And then we have those two loops, one nested inside the other one, in such a way that one of them is visiting, in this case, this one is visiting columns, this one is visiting rows. And how do we know it? Because j index is here in the column place, I is pointing to rows, and then every dij is created as the difference between xi minus xj. So this code takes about 1.05 seconds. It would be much more if we tried to increase this number, but Matlab may actually run out of memory with so big matrix. Now, what does it mean to vectorize? What we can try to do is write it in such a way that we get rid of at least one of these loops. So now we are getting rid of the inner loop, the one which was there before with the x, because what we do, now we tell that for the entire given column, so all rows in that column, what we will do is that in that place we will put our vector, and from that vector we will individually subtract the respective element which would be in the different columns. So This formula does the same job, but you can see that it runs less than half time of the previous case. So getting rid of this inner loop already is quite something. And if you think of it, when n is 100,000, this loop takes, 10,000, this loop makes 10,000 steps. The previous loop had to make 10,000 times 10,000 steps. So 10,000 times more steps than this one. So anyway, we have to say that the other loop was relatively fast, but still this one now runs less than half of this time. Further vectorization would actually mean that we get rid of this final loop. So let's see how that would be done. Well, we can do a trick such that we create, using our initial vector, we create a matrix where we replicate first the same vector many times, actually as many times as many rows it has. And then we make this difference of this matrix minus that matrix transposed. So this trick makes us again achieve that formula that it's xi minus xj. Good thing it's even shorter, the code. Bad thing is that this one actually works a little bit longer even than the first case, so than the one before vectorization at all. So you could ask why to vectorize? Well, there are two answers, speed and style. We have discussed speed already. And this is a relatively objective matter, if something is faster or slower. But in reality, these days, not every loop can be optimized because Matlab has built-in acceleration techniques. So sometimes keeping one loop, like we just saw, may save you a little bit time. But getting rid of nested loops is always a way to go. So make sure that you avoid nested loops whenever you can. And on the other hand, of course, the style is very subjective, but some people prefer looping things because it's easier to follow the code. Some people rather vectorize as much as they can because they like when the code is short.